Mr's Voice. Welcome to my new video on the electrochemical hydrogenation of vegetable oil. Presented by
The Cathode Chemistry Society, yo! Members are Neruchan, Mr. Size, Yan Chemistry ito, yo!
Anyway, enough of that. So, the setup. The setup consists of an anode, which is sacrificial in nature, usually made of aluminum, zinc, or any metal that will not emit oxygen under these conditions. We will learn why later. A power supply capable of delivering current and control voltage and current, a platinum catalyst surrounding the cathode, or a platinum cathode, the latter being better. An electrolyte that is either acidic or basic depending on the selected anode. Now we're gonna go to a video that will show you the setup. So Mr's Voice. This is how to make margarine using electrochemistry. First you need olive oil, platinum catalyst or wool. This is our cathode. It already contains platinum inside, and I'm just gonna pass current through this and it's gonna be partially submerged. This is our anode, made of aluminum, sacrificial, so we don't produce any weird things that oxidize the oil. Here's our container. We're gonna power this up and it should work real good. There are several advantages of this process when compared to your usual hydrogenation. It usually requires a source of hydrogen in an inert atmosphere, in your usual case, to prevent a fire hazard due to excess hydrogen and ethanol being present. This process only uses water as a carrier solvent and strong stirring. The disadvantages of the process, however, are apparent. It's very inefficient, it's not optimized, and it requires more cathode surface area to be optimized. The anodes need to be sacrificial and not inert ones because if they emit oxygen or chlorine, it would detonate on contact with the platinum, which is not desirable. The process is slow and very messy, probably due to the unoptimizedness of the whole thing, and it was very difficult to separate the gunk from the final product. Anyway, now we're gonna go to the rest of the video, which shows the various iterations of this process, along with the issues, but we'll go to that later. So yeah, the voltage is around 7 volts at 2 amps, and that spoon is to prevent this from touching, you know. I know it's very jank, but that's the point. I'm gonna replace this with a piece of cardboard later, just to watch. So this looks like a monstrosity. The voltage is higher, but trust me, this will work just fine. You know, maybe I should put platinum into the solution as well, but nah, I'm gonna try it this way and see if it works. Because I like to have it contained within the cage, it just feels right. I mean, the worst that could happen now is since there's platinum in there, there could be some minor pops, but there isn't anything really flammable in here. I mean, nothing really, so this should be fine. Either this means it's working, or this is just aluminum hydroxide forming a emulsion at the top. But the voltage has suddenly dropped. So yeah, I think something funny is happening. I had to change the setup a bit. It started to come up. Temperature's now 53, and now I'm using just holding it onto copper so the hydrogen gets diffused all throughout. And I also have the anode, no more membrane. Of course, I need to heat up the solution more because there seems to be a buildup of a waxy solid around the cathode. I mean, that's both a good or bad thing. You can see it there. But yeah, it's not melting, so I need to increase the temperature, and the only way to do that is to increase the amps. But that also means that you can tell by the bubbles that are going through here that's an inefficiency, because increasing the amps means more hydrogen is generated, more than what the catalyst can take. I hope to reach around 60 or 70 Celsius. This is much later. It's becoming hard to run. The catalyst is falling apart, getting caked. Voltage is everywhere. Current is steady. So the solution has been acidified further and mixed, but there's still a lot of solid that refuses to melt or react with the now strong acid solution, and I'm just waiting for it to totally settle out. So, our mixture now looks like this. There's a whole bunch of emulsion over here. Despite me acidifying the solution, it don't want to settle out. There's some white solid produced. The temperature is still really hot. So what I'm gonna do now is I'm gonna put this in the freezer. That should remove all of the oils, no matter what they are. And afterwards, the next thing to do is to then squeeze out all the water, like we're pressing olives. We're going ancient with this. We're back from the video. As you can see in their video, the final product became an emulsion. It was really sad. But for the life of me, I could not get that emulsion to break. Even try as I might with my old video on making aluminum tripalmitate, aluminum really sometimes doesn't want to behave when it doesn't want to behave, am I right? And as you saw in the video, eventually the stirring stopped because the margarine and the aluminum just decided to stop the experiment from going any further. There's only one final thing to say in this situation.
Yeah! That's all, people. See you next time, y'all.